Okay, good morning. To some people, good afternoon. Welcome to the second demo of the RhinoFab equipment. Today's Thursday. Thanks for everybody stopping. I think we still got more people coming in. So I'm going to just talk for a minute while they come in. We're going to be showing you today is Chris Draper is going to be going over some of the software, the Glazier Studio software. Give you a quick demonstration on that as far as how to draw a frame and how to present that and how to add hardware to a door. Then we'll pass it off to David, and he'll actually run a door through the machine. He'll run some extrusions. He'll run multiple cover caps, and at the same time show you the unloader, the brand new cart loader that Walter designed, and it's the first time out for this out of the barn. And from there, we're gonna move over to our shop floor software, but with Chris again, and just to show you what we got coming out. It's not quite yet live, but this is what we got coming out, just to kind of give you a glimpse of the future of what we're doing here at Rhino and to the Michael Group, to give you an idea what's coming in the future. Okay. All right, Chris, you ready?
I am ready. Yep.
Okay, we're going to turn it over to Chris Draper. Todd, you want to give Chris the reins?
Okay, you should be able to see my partner pack Glazier Studio screen here. All right, I want to thank everybody for joining us today. I'm Chris Draper. I'm one of the software engineers here with the DeMichael Group and work primarily on Studio and then some backup on programming for the Rhino and some of the new assembly station software that we got coming out. But we'll talk to you a little bit about Partner Pack and Glazier Studio. Those are our two estimating, fabricating, shop drawing software that we have. Both programs are 100% identical. It's just Partner Pack is a Conure specific product, and Glazier Studio is branded for all of our other catalogs that are out there for your major other metal manufacturers and some of your regional catalogs as well. So what I want to show here today is we're going to build some elevations. I want to show you how easy it is and how much already is set up in the software for you for when you do have a Rhino, that it can just translate straight to the Rhino. And then with all that information that we can take and then move forward down the process, whether it be to assembly and other parts, within your operation. So what you're seeing here is sort of the main screen of our software. We have our databases, we have our fabrication, and then other types of reports. So not only is this just an estimating tool, it's got all the fabrications built into the metal systems that we predefine with each manufacturer. That will be like all your assembly holes, your weep slots and those kinds of things, that are kind of standard within the installation instructions for each vendor. So what you're kind of seeing here is the main screen of the software. This is where all your projects would be listed here. So to kind of get started, I'm going to just go ahead and hit new, and we're going to just create a little sample project here, create a project. Like I said, we pre-build up a lot of every variation that the metal manufacturers offer. And so for instance, here, I'm just going to choose a storefront stops up system, and then you can choose your finish, what type of glass, and then you put in your parameters of width and height and how many openings there are. So maybe I'll just do 3 here by 2 and 108 inches tall. And then we'll go ahead and hit add frame here. So what we're looking at here is this is the elevation where you're designing and laying out based off of your shop drawings or whatever you have. And then you're just kind of working with the elevation. So for instance, I can take a row of horizontals and I can just move those to 24 inches. If I want to set a daylight, I can just click, start typing, and hit enter a few times, and it's going to automatically adjust the elevation, keeping track of where everything belongs. And the nice thing with this is while you're building these elevations, it's also keeping your bill of materials, it's keeping all your fabrication information, all of that's already then, in there and set up for you. So you kind of go through and you're just building your different elevations. Maybe that's your first one. And then now we're going to go ahead and we'll add in a door here. So we can come here, I can hit right click,
Hey,
and let's say
Chris, sorry, I lost your screen.
uh, Okay, is it back?
Yes.
Okay. So I built one little sample frame, and now I'm going to build another frame with a door. So I'm going to go ahead and we'll insert this left-hand door here, or left-hand door. So you go down through and you make your selections. You know, this is all kind of based different for each vendor, but as you make, you know, your selections, you know, hinging and maybe, you know, a medium style door, the program's automatically going to choose these numbers. So now under hardware, you can pick up, you know, different types of hardware, and you can assign fabrication preps to those hardware so that it will automatically then apply all those preps and fabs to the frames, to the exploded doors, or to full door leaves. However you build your doors, it has all those capabilities built in. I'm going to go ahead and hit OK. We'll put this door in. You know, so from here, you're just kind of setting up all your elevations. Now this will handle, you know, curtain wall with splicing and anchoring. You can, you know, predefine that this, you know, unit is going to be set to be assembled. I want to assign it to this cart. I want to create units. So on a unitized curtain wall, you can define what the units are, and then that way, when it comes all the way out to the Rhino and out to any other software, it's going to have all that tagged separately, and then we'll be able to scan those and work with those. So I want to show you now. We'll take you into RhinoFab and just kind of show you what's already pre-set up on the sticks and the doors as they come in. So
Hey,
I'm going to
Chris,
come
we
over
just
here.
lost your screen again.
I don't know why. Okay. All right, we're back. So from here, I'm going to go now into metal fabrication, and I want to import this project. So we'll choose demo here. We'll bring in both of these frames here. So right now it's just gathering all the parts and pieces. It's labeling, you know, giving unique identifications, you know. So from here, if I take a look, so here.
Sorry, Chris, it's
Oh,
off again.
I don't know why I would do that.
Yeah, just bear with us, everyone. Chris is just having to reset his screen.
Okay, so I brought this into RhinoFab here, and so if we look at this screen here, it tells us, so that first elevation, here's stick one, which is our left jam. So if we look at that stick one and what fabrications it put on, so we can see all the assembly holes that it automatically assigned to that stick. So all this is going to be done for you. Now you can come in here and add, you know, slots, sweeps, rectangles, route outs for different anchoring, for any kind of electrical devices that got to be ran through. Any of that you can then kind of add, you know, as needed. So, and all of this is also available in sort of like a 3D view. So if I click here and just kind of scroll in and spin it around, so it kind of gives you a visual representation of that. You can see what fabs are being applied to each stick. Let's go ahead now. We'll go into door fabrication, and we'll import that one door here. So I'm going to bring this one in. So
You have to reset it again.
Let's just do this entire screen. Maybe that will help. And then we'll jump. Okay. All right. So I brought this door in, and so like I said, if you apply your fab libraries to the hardware, those would automatically come in. So under our Fab Rules library, we've set up, you know, an extensive library, and this is kind of always building and growing, of different exit devices, hinges, locks, you know, pulls. There's, you know, for closers and, you know, EPT10s and those kinds of things. You can set up this whole library and have them, you know, be applied to the door or to the frame, or you can also use them for other things within the frame. So coming back to this door, I want to go ahead and I'm going to add some hardware, and this is kind of what we're adding this hardware. We're going to send it out to the Rhino, and that's what you're going to see kind of, you know, applied to the door. So I come into my add library, and I want to maybe add some hinges. So I pick my hinge preps that I have, and just say I want them 10 inches from each end. I hit apply, and maybe I want to add a lock also. So I'll click on lock there, and here's my lock prep, and maybe that's at 35 inches. And then I hit OK. And then so now it's added all. So this is the 2D view. So now if I go to detail view, I can kind of scroll in and I can see that my lock cylinder and my lock cutout and stuff that's going to be prepped. And then also I can see, like the hinges that are going to be applied to this door. So very quickly and easily, it's all the fabs are kind of like setting up like in a spreadsheet. You just kind of, it's X and Y's and, where everything's located. And so it's very simple to set up, and we kind of help you through those processes here as part of the software. So one other thing I wanted to show that kind of ties in back into the what we're going to be kind of showing at the very end with the assembly is we do have a phone app that you can take and upload any of the projects that are in Partner Pack or Glazier Studio can be uploaded to our app that's available on Android or iOS. And what it does is it allows you to share information with the app, so you can use it in the shop, you could use it out in the field. And so I could take this project, I can upload it. And so I'm going to kind of show my phone here, and then we'll get that so you can see what happens here. Okay, so this is the app here, and if I come to projects, I can see those same projects that I had on my studio software, and so I can open up those, and here's the project information. I can pull up the different frames, and so this could be, I'd be out in the field, and so maybe there's some field measurements that got to change. I can do those and send those back to the shop. I can share images, with, let me go back to this project, and I can share images. So if I'm out in the field and I take an image of a frame and I need to add some notes, I can send that back and forth. And it's just a way to communicate with the people in the office of, what's going on with that project. You can share files, like I could upload any report that's in Studio can be uploaded to the app and shared there. And you can create tasks. So every project or every frame could have specific tasks created. So like, for instance, if you want to know when a project is completed, a frame is installed, or a unit is completed, or the glass, or, it's an endless list of tasks that you can create and develop on your own. But kind of what we're going to be showing here today is once a project is completed, it's loaded on the cart, you go to an assembly. So we have the scanning feature where you can scan parts, you can scan barcodes for a completed unit. And, at that time, you could then send back that the unit is complete or that frame is complete. And so the possibilities of using this are kind of endless and open to many different things, but I just want to kind of share that with you. And then just so you can see, like back here in the office, I can come in and I can look at that same picture that they took. So I can view that and I can see that. So just a kind of way to communicate. And
Looks like Chris may have frozen up. So he was coming to the end of his portion. You back there, Chris?
I am here now.
Hey, there you go.
Yeah, sorry. So I think you saw everything. What I was going to say is now we're going to turn it over to the people out at the Rhino and get started there. So yeah, at the very end, there'll be some time for questions if you have any questions about what I showed or anything like that. So.
All right. Thank you, Chris. Just give us a second. We're going to switch over to our next presenter.
All right. Camera's on. Everyone can see me?
Yes, sir. Looks good.
All right. Good deal. Cool.
It's a little,
I'm
a
Dave.
little crooked. It's a little crooked, but just bear with us.
I'll lean this way for you and we'll make this work. My name is David. I'm going to show you guys the RhinoFab that we've got set up here. I know a couple people kind of start talking about it a little bit, so I'll keep it brief and explain to you what it is. This is our 9700 combo. This is going to be the extrusion machine for processing lineals of storefront curtain wall or any aluminum extrusion. And it also has the door blank capacity. So this one's stretched out real big this way, so you can fit a 48-inch wide door blank through the machine as well, and get that all fabricated. Over here on this side, going to look like a traditional RhinoFab. Difference being is this one has the ball tables for rolling doors around and moving the door in and out of the machine. They're on lift cylinders, so while you're running stock lengths, the conveyor belts are accessible for the machine. And when you guys switch over to door mode, the machine will automatically pick everything up and move stuff out of the way so that you guys can push doors across this. Inside of the cab, we've got our 36,000 RPM routers. There's 3 of them in here, top, back, and bottom. And also we have our automated tool changer up there. It's a 20 carousel tool changing station. The robot has 2 grippers on it as well. And this robot will automatically move to any of these pinned positions here to pick up a tool as needed throughout the job. So at the very beginning of the job, right in the middle of a stock length, anytime. So it's going to switch tools out, move things around, and get going for you, so that you don't have an operator in there trying to move tools around or switch tools in the middle of a door to go from a thicker bit to a smaller one for tapping. On this side of the machine, we have the saw cabinet. These are going to be down cut miters and a back cut bevel saw. So the top saw is going to be the primary saw for any of your typical 90s and any miter type cuts. Curtain wall and storefront guys that are in here, these are going to be like corners or any kind of radiused frames, serpentine frames, anything like that. It ranges anywhere from 45 to 135 back around the other way. We can do any interval in between there, 45.1. 50.1, anything like that. And the same thing with the bevel saw in the bottom. It's going to do the same thing, but these ones are going to be for our traditional bevel cuts. Same concept. If you're a curtain wall and storefront guy, it's going to be the frames that rake down, right? A rake top frame or any slanted part like that, or face cap at a corner position or anything like that. That's got to get that style of cut, right? So 2 saws in there. On the outfeed side of this machine is the new unloader system. This one is going to have a gripper system built just like the original unloader system, where it reaches into the machine and pulls your parts out and pulls them out here. And you'll get them to be placed on a conveyor system like this. But in addition to that, on this side, we have an additional pusher system with arms on it. And the goal of these arms is to come out and grab the part off of the outfeed rollers, and it loads them onto these carts. The carts are all stationed on the floor to exact position. This way you can roll the carts over into place, and as the machine optimizes, it'll tell you, I need a cart here, I need a cart there. And it'll bring these parts out and put them on the cart for you and continue to run its cycle while the machine's working. So ideally, the goal here is to load 10 stock lengths on the conveyor, hit the start button, and be able to walk away from the machine and let it continue to work while your operator is able to go do other things or get other processes ready. The carts are all tied to a database. It's an intelligent cart. So as the cart gets loaded up and is removed from position, the cart is going to track in the software what parts are on it, what position they're in, if they're KD'd, if they're assembled, if they need to go get gasketed, anything like that. It's all tracked through the cart. Over on the other side where you guys will see the assembly table, Chris will kind of show you that some more when we get done with this little part of our show over here. But it's a complete system from the very beginning. Material comes in, goes onto the machine, runs through the machine, and gets automatically unloaded on these, and it gets tracked stage by stage by stage until it's ready to go out into the field and get put together. So to start, we're going to run a stock length. I've got some Conair curtain wall right here. Just going to do some normal stuff that you guys are used to seeing. When we get done with that, we have a stacking routine. The stacking routine is for, right now, we're going to do it with some face caps. The face caps, they're small profiles. Ideally, they get cut a lot the same. They get fabricated the same. So we want to be able to run more than one through the machine at a time. So we have multiple options where you can stack multiples on top of each other. in and out, left to right. Sorry, I can see the camera still leaning. If you guys are getting sick, I'm sorry. Um, but the idea is that we can stack multiples of these together, and the machine is going to take all the data that we send it for one part and combine it into two and re-optimize it as two parts and move whole locations and adjust things so that everything still gets fabricated accordingly. So once we get done with the curtain wall mullion, we're going to run that face cap, and then we're going to switch over into the door mode. And I've got a standard medium style door over there. We're going to push it through, do a bunch of cutouts and stuff on it. I'll explain what all the hardware is as we go. And we get done with that, we're going to send it back over to Chris to the assembly station once we get some parts on carts here. So get started. I'm just going to run the job here, pull this up and let this thing get started. As the stuff gets running through the machine here, got to close this door. I'll start to explain, which tools are doing what, how everything works. Close this safety door. And how everything is meant to go through and kind of explain to you the process here. I'm going to mute myself in between what I'm saying, but while this stuff is running, if anything, if anyone has any questions about anything, feel free to ask in the middle of it. The machine, for some reason, through my microphone here is deafening, so I'm going to mute. And when I need to talk, I'll unmute. But if you guys have questions while it's running, we're going to have some time here. Feel free to ask. So I'll get this thing going, and we're going to switch the cameras over to the inside of the machine and get everything moving. So we've got this set on the furthest point of the autoloader here. We're just going to let it get pulled through and pushed into the machine. Go ahead and hit OK here to start it. All of our clamps move into position. The pusher comes back and the parts advance on the conveyor. We've got a sensor built into this so that when it reaches its load position, it'll stop and it knows exactly how far to index to get this thing on here. Pusher knows exactly how far back to go so that we're not having a bunch of dead time between the push and when it's actually going to start. We measure every stock length right here. You see a small pause. We just got the measurement of this stock length to the T so that we can make sure that the trim is going to be accurate. All the cuts are going to be accurate, and we're working with the right set of parameters here. So we in the machine? We in the machine on the camera? Good deal.
Yes.
All right. If you guys have any questions, like I said, I'm going to mute myself so you don't have to be static killed through my ears, but I'll unmute as you guys ask.
Yeah. The microphone, the mute has been turned off, so attendees can ask questions. Feel free to ask any questions that you do have. If you're not talking, just mute yourself so that your background noise doesn't interfere.
All right. Nope. Wait till this gets done cutting here. So what we just saw was the countersink tool for just traditional horizontals. This is a two-part tool. It's a drill bit with a countersink on it. This allows one function to drill the hole and countersink it at the same time. This way we're not working through robot tool changes through this process. Mhm. When this part gets done cutting, what you'll see, we're going to switch the camera back over to Jeffrey, and you'll see the gripper system picks apart and pull it
Wait,
out.
I got a question for you guys.
Go ahead.
Would you guys be able to do a demonstration on a miter cut, both programming and on the actual saw?
I don't see why not. Like, if we can get to the end of this here and kind of go through the cycle here,
Yeah.
we should be able to knock it out this way. If there's a lot of people in here that have kind of seen those things already, so if they don't want to sit here and watch us go back in the office and program. But yeah, for sure. If you want to see something specific, I don't mind at all.
Yeah, I mean, just on the programming, and obviously, I don't have the machine you guys got right there. I got it on the what is mine? The 1150. So it does cut. I just do have the top saw, but it does have the miter cuts. So I just wanted to see on that on the programming end of it, because usually when I build a frame, I'll have like a corner adapting post, but I'll build it in two separate frames, if that makes sense.
No, understood. Yes, sir.
Okay, cool.
Yeah, let us get through the demo completely. That way we can be done, and then we'll show you. Okay.
Perfect. Thank you. Appreciate it.
Did you turn your speaker off so you couldn't hear the machine or something?
I just muted it because the audio coming through my headphones apparently is makes it 1,000 times worse. So usually I just
Oh,
mute
gotcha.
myself so that you guys don't have to listen to the tinge coming through my earphones too.
Okay.
So between questions and stuff, I'll unmute. But so what it's doing, it's unloading these and it's tracking these. As every part gets loaded, it's predetermined where it's going to go on those parts. The software does that automatically. It's going to pick everything up and it's going to say, okay, I put this head, this horizontal in this position on this row on this cart. If we kind of come around to the side over here of this cart, you can see the labeling system that we have on it, and we can see the robot, or I'm sorry, the unloader kind of move back and out of the way here. Ideally, what we always want to see is we don't want to see any processes stop. Right? So what you saw there where the unloader came down and came all the way over was it was getting out of the way so that the machine and the parts coming out of the machine can still come out at the same time. This way we're not stopping and waiting for anything to happen. We want to be continuing production during the unloading process as well. So the gripper system, again, grabs our part, pulls it out, sets it down. And on these smaller pieces like this, we got to reposition so that we can push it far enough for these hands to grab it. The longer parts, you don't have to worry about it. We pick up that center of mass and we push it out wherever it needs to be and everything that's good. Anybody got any questions on any of this stuff that we're kind of walking through right now? You're going to see some verticals come out that are a little bit longer, and then we're going to switch over to the face cap stuff.
Are you going to be able to show us how the labeling process works with the cart unloader?
So the labeling process on this one is going to be post-machine. So as we kind of migrate this around to the fab table over there, or any of the other departments after this, is where the labeling is going to happen. So now, as we kind of are working through it, what we want to do is keep this machine running without the need of an operator to stand right here with it. So as it moves from one station to the next, we're tracking where all these parts are, and there will be label makers at the next station of production. And if you need labels for a specific part, you have the ability just to click that part right on the cart screen and say, I need a label for this part real quick. But if not, and we kind of work through the flow of how this was all designed, then the need for labeling becomes very minimal, right? We're tracking it through. You're pulling this part off. You're steering it to the vertical, or you're putting a steer block on it. And then if at any point it needs to go to another station, like a gas getting station or anything like that, it'll know, okay, I need a label at this point, and we're going to create a label for it because it's now going to be removed from the part or from the cart and not put back. So as long as we're staying through the process, the labels really aren't necessary until we know the part is going to be removed from its known position. And at that point, we can label.
Right. So what we did is we just moved labeling from the machine to wherever your next station is, where you remove it from the part. That's when you actually apply the label. Okay. Whether it be assembly, packaging, palletizing, everything will stay on the cart till it goes to one of those departments, and then as you pull it off, then you'll create the label there. Okay.
So what I'll do is I'll explain to you this stacking stuff that we have here with the multiple parts and some of the fixtures that were designed to do this. I've got a couple of fixtures right here, and we'll switch the camera over to me so you guys can see me. Oh, I need nothing. Oh, unmuted. So good. Okay. So with the stacking and running multiple parts, like I said, the concept is to obviously be efficient as possible and run as many things as we possibly can. What ends up happening is when you start stacking thin or flimsy parts, there's the need to make sure that things aren't going to fall off each other while they're running. So we've got these fixtures that we've made that easily mount to our parts here. In this case, we're not really going to need it for these face caps. They sit pretty good, but like a pressure plate scenario where it's not a perfect rectangle or a shoe shaped item, we can put these blocks on, and these blocks are all numbered for positions. So if we were going to run 4 of these face caps side by side, being a 2.5-inch face cap, we would want to put this at about 5 inches, and we lock it in, and we can stack 4 of these face caps together, and these just help it from the parts falling off of each other while they're working. This stuff, we don't really need it, so I'm just going to pull it off. We could leave it on. You would get a couple of these, kind of position them down the thing as you go, but for what we're doing, we don't actually need it for now. So I'm just going to grab these parts, or I'll have actually Branson grab these parts. And I'll walk over here. This way we can keep the train rolling here and get them put on. So Chris is going to load the job up for us and get the face cap part ready, and we'll watch this run. We're just going to run a couple of these, let it cut and drill, do all of the part switching. These were yesterday's. These are the ones we want to use? Okay. Good. Okay. So in here, when we're running these, we're going to select that we want to run the 006. And we can come over here and say we want to stack 2 of these, or we want to stack 4 of these. Ideally, you don't want to do an odd number, right? We want to kind of stay nice and tight. So we're going to say we want to stack 2 of them. We'll hit the select button. And at this point, it re-optimizes the whole list here and combines a pattern. And so what we'll see on the screen here when it gets done thinking about this and checking the carousel to make sure we have everything, it tells us that we need one stack of two parts, right? So it's just another way of making sure that everybody's got what they need in place. This message right here is just telling us what cart goes in which position to make sure we're going to load these things okay. Cart number 2 goes in anchor point 1. Cart number 4 goes in anchor port number 4. So that we have set up already. And you can see here we've split these now into 2 separate pieces. This way you kind of see that you're not just getting one. We have an orientation image right here, so we can see how we need to stack these together when we do 2. So I'm just going to hit the start button. We're going to let these guys run through, and we're going to switch over to the door mode, run some doors. So with this, the big thing for us to accomplish was to make sure that we're still going to be able to weave these or fabricate basically any of these parts that we run through. I mean, if you decide you want to stack 2 storefront verticals together and run those, again, completely possible, but we still want to get all the holes. So we automated the process to make it so that you would still program the same exact way, but when you send it to the machine does all the flipping and the managing of fab. So as this drills, you should be able to see that these holes are still going in the right spot, still doing everything it's supposed to do. We're just doubling up on how many we're able to get out. Okay, we did a little bit of unloader action here. Same process, going to work the same way because we've got it. Let this guy pull out. If you guys don't have an unloader, obviously, it's just a matter of having an operator pull this stuff out and stack it and label it at that time. The carting system is going to maintain this too at the same time. It's got 2 pieces now in position 1 on row 4. The unloader gets out of the way. The machine keeps working. We're able to kind of keep cycle times to the minimum here. All right, there's all of our face caps. So what we'll do now is we're going to switch over. We're going to run some doors, get into some milling here, hardware preps. Chris went over some of the programming and stuff. I'll kind of touch on that here a little bit as we go through this. Uh, when we designed this and created software and tried to figure out the macro situation, how we were going to store all these library fabs, we wanted to create a universal concept or logic so that the same piece of hardware could be applied on a left-hand door, a right-hand door, reverse version, a single door, double door, all of that good stuff. So at the machine side, what we'll do is we're always going to put the door onto the machine the same way every time. It's going to go top rail first with the pull side of the door up in the air. And what the machine is going to do is it's going to look at the door and the data that comes with it and say, I'm a left hand swing out, or a hinge right swing in, or left hand reverse, whatever nomenclature you're used to. It's going to take the data and interpret it accordingly so that you don't have to worry about changing the orientation of this door when it runs through the machine. You just put the machine on the rollers, let it push through, and the machine is going to know what to do from there. Ideally, the operator and the programmer are going to be probably two separate people. And so making sure that information doesn't get lost from the office side to the machine side can get a little bit tricky with that stuff. So we decided to take out any risk of that happening, and we controlled how the data gets oriented on the door. This way you guys don't have to worry about it. So I'm going to switch everything into the door mode. It's a very quick thing. As soon as you select a job on the machine that is a door, everything will move accordingly. It pops up, tells you to make sure any safety things are taken care of, not in the way. The roller tables come up. The auto loader rollers go down, and everything gets into the position that it needs to be. So we're going to go into this. We'll get this door running. We're going to end up with this having 3 hinges, Glenn Johnson. We're going to throw a MF lock on there and a panic. So you're going to see quite a bit of stuff. The first side that runs through on this door is going to be your hinge side. So you're going to get that Glenn Johnson cut out right out the gate there. And then you'll see some hinges go through, and then I'll kind of walk you through the process of how we manage the opposite side of the door. So we want to run the hinge side first. Goes through all of our checks here. And then Branson, if I could get you to load that door up there, and Jeffrey, show him how that door goes on there. The other thing I have to make sure of, we can come back over, is I have to make sure that the parts are off, and I don't have at least this cart here, because the door is going to push through. It's a 36-inch door, and we don't want to turn to this cart. So it's a good time. I can show you at least how we station these things real quick before we move on to that. They're positioned based off of these plates in the floor. These get anchored to your floor, and they're going to stay in that position. They're very low profile, so not much of a tripping hazard at all, if any. And then the carts are just going to roll out of position. Maybe. There we go. The wheels will agree with me here. And it comes over, and from here you'll move over to assembly station or a gasketing station, depending on which part of the production is next. So these plates, they don't move. Like I said, they're locked in here. They're not going to come out, and you really don't have to worry about tripping on them because there's just a small hump in the ground. So we'll go ahead and get this door going through here. So the first run with this door, it's going to be top rail first with the hinge side up against the fence, just because this was a hinge right swing out. Another time might end up being a hinge left swing out, which means the locks, or anything on the lock side of the door is going to be the first side. It's just this scenario here with this swing of this door made it be what it is. So what you'll see is the door is going to get pushed through the machine, and we're actually going to measure this door with a hard stop. The reason we do that is we need a 100% accurate measurement of the door here so that we can maintain fab locations when we spin this door around to run the opposite side of the door. Everybody knows that, you order a 84-inch door and it ends up being, 83 and an eighth rather than 83 and 3/16. And we got to make sure that we're offsetting those holes so it matches the opposite side of the door still. So this is going to be that big Glenn Johnson arm across the top side of that door. Is the audio all right today? Is my headphones kind of killing it here, or can I be closer? Sounds okay? Sounds all right. I'll keep my distance and try not to. But if you guys have questions about doors and door hardware and the process here, feel free to ask. In the meantime, what you see, the tool we're using right here, this is a countersink router. It's very similar to the countersink bit we use on the curtain wall horizontals, except for this one has the capacity to also route. Right, so we can go in, we can hit those countersink holes with the router bit as well as do the cutouts for the hinge locations too. This way you're not switching tools. Just to confirm, Todd, all the attendees, they're not muted right now, are they?
That is correct. They are not muted.
Okay. All right.
So
If you guys have, yep, go ahead.
Yeah, if anyone wants to ask a question, just go ahead and unmute yourself and feel free to ask away. We have some people from yesterday, so there's not as many questions.
All right. So as it finishes up that last hinge, the software is going to prompt us on the machine to spin this thing around and push it back through so that we can hit the other side of the door as well. So what I'm going to do is I'm going to push it back to the other side as soon as I hit this OK button. Push it through that way, and I'm going to come over here to where I have the ball tables here, and I'm going to spin it over here on the ball tables. The idea of these were to make sure that we're not going to scratch the door, but also have a nice, easy way of getting this spun around so that it's not flipping or picking this thing up and moving it around in a very difficult manner. So what we do is just bring this guy around. We can see some of these cutouts real quick. If we get this camera a little bit closer here, just a little hair right here, just pull that guy off. But we've got the countersunk holes for the backer plate, the hinge cutouts here. Same thing on this guy, just a little hair here. So I'm going to push this in. On this side, you're going to get MS1850. You'll also get a Von Duprin 99 with some trim. The other thing you're going to see on this side of the door is a tool change. We need to change the tools, so the robot is going to go through the process of changing the tools. So when it goes to do that, we'll make sure that the camera's on there so you guys see this thing move. I'll just hit this continue button and let it go. And again, if you guys have questions in the process here, feel free to ask. It doesn't have to be about the doors. It can be about any part of this whole process here.
Hi, this is Val. I participated yesterday but forgot to ask. Will there be a recording of this demo potentially uploaded or that we could receive it if we asked for?
Yeah, I believe these all get actually uploaded to YouTube. I've had a few people ask me if I'm the guy on YouTube, so I assume that this one will also make it up there as well.
Okay, great. Thank you.
Yeah, definitely there is a recording, and we'll be sure to send that out. So just switching out tool, we could have very well easily accomplished the same cutout with the same tools that we had in there. It's just nice to show you guys this robot and how it can quickly and easily change tools and in the middle of a process, right? So that one happened to have started right before we started fabbing, but if it does this cutout and it needs to switch after this cutout to a small drill bit or anything like that, it'll go grab whatever it needs right in the middle of a run. The other thing you notice is we can simultaneously run all three of these routers at the same time, right? Picking up efficiency a little bit. They go through a series of checks to make sure that none of the drill bits are going to collide. So with this being the MS1850 and having those cylinder cutouts very close to each other, there is a collision there where the two bits might run in. So what the machine does automatically is it makes one run first and then it picks up the other ones afterwards. This way you don't end up busting bits off by running themselves into each other. So that was it. It's done. It just ran the MS1850 and the Von Duprin 99. So we'll pull it out. I'll spin this door around so you guys can see it. Same process. And if you guys have any questions, again, feel free to ask. And if not, we're going to kick you right back over to Chris Draper. And he's going to show you guys the carding routine. Or I'm sorry, the assembly station. Forgive me. Okay. Thank you, David.
Yep.
All right, we're going to move over to Chris Draper.
All right, Jeffrey's making his way over here so we can show you what we got going on over here today that's brand new and how this answer some of those questions with tagging and the whole cart unloading and the assembly area and different stations like that. So what we got here today is we've got a sample cart that was completely offloaded. The idea is that while the Rhino is still working and cutting pieces, you're going to have some finished carts. You're going to have some elevations that you can start building and working on.
Huh?
So what we got here is we have this cart, and we've got all the pieces loaded here. And so
that's our cart. And then over here, what we have is our Rhino assembly software that we've just recently developed. And so what it does is it gives you the ability to scan carts that are at your station, or you can go in and I'd say, I want to assemble a project. And the software will then look up what is available to build based on what carts you have over in your area. So if I come over here and I click on scan carts, then I can come over here, grab my scanner, and then I'm going to come over and scan this cart. It'll show up on the screen here, and then I'll just go ahead and say okay. And so what it's going to do now is see what project I can build that's on this cart. So here's this project, and what it's doing is it's linking between the studio software and the Rhino to determine what's available, and then all this project information comes along with it here. So I'm going to say build this project. So right here on this screen, it's going to tell us what, over in the top left, what elevations we can build. In the middle, we're going to see what's all on this cart. It automatically highlighted the first elevation that we can build. And so we have a list of all the parts that are here. We have if I bring this image up, so over on this screen on the right here, we have the same layout drawing that you would see in the Metal Fab screen of Glazier Studio, kind of giving the full layout of each stick. And so one of the questions is, well, how do I get, my barcode? So anything that is highlighted in this grid here, I can come up here and I can hit print, and I can hit print part tag. And so what the machine, the label printer is going to go ahead and print out. Now this may be your assembly station that you move to. It may be, we could have this software at your gasketing or the different steps along the process. So as you pull parts off, you know where they are, where they belong, and you can print those tags to go along with it. So the other thing is we'll say somebody now shows up with another cart or maybe a pallet of something. I can come up to carts here, and I have like a pallet tag here. I can just scan that, and so now I have a pallet, and I can hit OK, and now that pallet information now shows up with what's on that pallet. So all those parts may belong to this curtain wall frame that we built that has multiple units. So on a large curtain wall elevation, if I click, well, what units can I build? So it's going to highlight these units here. And so I'm going to build this unit here, and here's all the parts that go with that. The other nice thing it provides is under hardware, vinyl, and glass. So it'll give you a full pick list of everything that you would need to bring over to this area in order to assemble these elevations. So the process would be kind of, okay, I'm on this frame, and the other thing you can do is over here, you can just highlight this one stick, and it's going to tell you where that one stick is. You can do the same thing by over here. You can click different line items, and it'll tell you exactly where those items are located. So what we're going to do is we're going to go ahead and we're going to build this elevation. So we're also going to keep track of how long does it take to build this elevation. And so what we would do is we would hit start here, and it's going to kind of keep track. And so what we'll do is then we're going to move and we say, okay, so we need out of, row 2 here, we need stick 1. So we're going to grab this. And so now what we're going to show you here is another thing that we've also developed here is our assembly table. And so this table here allows you to look at what's on the screen and kind of give an idea. So this whole opening is 38 inches. And so you can kind of guide this, and there's a little digital readout over here, and you can kind of get close to where the 38 is. And so you line up your piece, and then you go back to your cart, and you would grab, the next piece. So I'm going to grab, stick 3 here, which would be the sill in this case. And so I would come over and I'd lay this up, and you'd kind of repeat this process. You'd add your other vertical in, you'd add all your parts. And once you get it, close to where you want it, there's things where you can lock down the whole machine and kind of get everything locked and tight. There's these little knobs here where if you need to get it really tight for like a shear block to kind of clamp everything together, you can do that as well and get it just real tight. And then so from here, you would have your hardware, you'd have your screw guns, the different trays set up for that. And so then you would just go and you would start, assembling. So one of the other unique features of this is, you've got your snap-in male side to a vertical like that. And those profiles aren't the full 4.5. And so what we have is these little things here that you can adjust for different heights. And so, that 002 snap-in would sit on this. And so that would bring it level with your other members, and then you would still be able to screw and adjust it from there. So, and all of these can move and everything. And so this table can also be extended out to be, another 12 feet, you get 2 or 3 of them. So you could have, different things like that. So once we get our elevation complete, we'd come back over to the software. And so from here, what we would do is, okay, we completed that elevation. And as soon as I hit complete, now it printed a frame tag here. And so one of the things that now you can use our app with is along to go with this. And so I'm going to come back into my Glazier Studio app. I'm going to come to the scanner. So now say I'm out in the field and, I want to, or I'm in the shop and I want to mark this complete so I can update the people in the office. So I'd come in, I'd scan that frame. And right here, it's going to tell me, well, that scanned a stick. Let me scan the frame here. All right, so scan this frame tag. So it's going to tell me that this is that frame. It belongs to this project. And so from here, I could say, well, take me exactly to that frame. And I could go into that frame. And then I could also create a task for this that I could say, this unit or this frame is installed or completed. So it kind of completes the full circle of being able to communicate when things are done in a certain area within the shop or out in the field. So is there any questions on this whole process or what we've got here today that we've shown you?
Hey, Todd, can everybody speak okay?
Yeah, they should be able to.
Okay.
Quick question, with the cart unloader system and the kind of standalone workstation for processing that final product, is that standalone workstation something that can be purchased separately, or does it have to be associated with the cart unloader?
So everything can be purchased, completely separately. So you could have, one of the other things I can show you, if you come back over here, Jeffrey, is we set this up, this software, to where if you go to just assemble projects and you have a bunch of carts for this project, the other idea is that you can use your own carting system. You can build up like your own A-frames or other different types of carts, however you do it. So you can unload it onto your own carts and keep track of it that way. Then also you can get just the assembly table all by itself. There's this assembly station software can be completely separate. So we kind of mix and match everything, or you have the whole package as well.
Okay, and probably a question more for Bill Cole and his team, but price point on the assembly software table, stuff like that, is there an idea on that yet?
We don't have an idea yet. Well, we have an idea, but we don't have an idea. So
Perfect.
we haven't locked it in yet. We're kind of showing you what what we have. This actually does work. And what we're coming out with probably, first quarter, okay, of next year. So still got a couple things to work through. Of course, we'll have some beta testers for this, to work through some of this stuff. But, the key to this is exactly like Chris said. You're going to have, it doesn't have to be two big monitors like this either, right? It could be a pad, okay? And you can set these up at every station where an activity takes place. So if you're, if you got KD and you're just wrapping, say you're wrapping up horizontals to go, on a pallet. Once it comes off that cart, you're going to label it there. You're going to track it. So if you're at, a wrapping station or a shipping station, wherever it goes, it'll track that station, the time it got there. Now you know where it's at. If it's been shipped, if it's been received, if it's been installed, and the times in between, and you can track that as closely as you want to monitor that, Okay. So that's the whole key to that. All right.
Is the connectivity on this local to the one machine, or can it be networked and processed through multiple machines and multiple branches?
Yep. We can network it. I mean, if you're on a cloud, we can network it among multiple machines, multiple branches.
Right. The idea is, right now I'm running from studio in the office to Rhino. It's all at the same facility, but there are those that have, the Rhino may be on a separate network. It could be at a whole different location. And so all we need is that cart data to be up into a cloud, which is a lot less data than, say, if we were to, processing all this other So, you know, that could be a setup as well.
Okay. Anybody else got any more questions for Chris? I see Jim Trout in here. I know he's got a question. I see Mike Trout. If you're in Florida, you're wrong, you know. Okay.
So all those that come into the glass build show will have all the same stuff there at the glass build, and you know, stop by and you know, say hi and check it out, and be able to answer a whole lot more questions. If you want to see some more specific demos on anything you saw today, we can kind of set those up as well. And so.
Okay. And then Elliot, I know you can hear me. We got your parts. I think we ran 3 of them. We're gonna run the other 2 today or tomorrow. Give me a call. I shot you an email. Give me a call when you get a chance. Okay.
Right, thanks,
We
Bill.
can show you online. Okay. All right. Oh, there you are. Yeah, we ran some of them on this machine here, which is exactly what you're getting, minus the big cabinet. So I'll give me a call after you get out of this. Okay.
Sounds good. Appreciate it.
Okay, guys, that's it for the meeting for today. Thanks for stopping in. If you have any questions, shoot me an email or Chris. Feel free to call me, and thanks for stopping in, and have a good day. Okay.
Thank you.